Hello, and welcome back to our course on Descriptive Data Analysis. In this class, we are going to study the relative position measures. The relative position measures are used when you want to know how a given value, for example, a score, compares in relation to others. To illustrate, let's consider the case that you have a grade of 6.3 in an exam, but you know that the average grade of the class is, for example, 8.2. By comparing your 6.3 grade with the average grade of the class, you can conclude that you perform relatively poorly in relation to the group. We are going to study two relative position measures here. The first one is the so-called z-score, and the other ones are based on the quantiles. The z-score is calculated by taking the value that you want to compare, subtracting it by the average, and dividing by the standard deviation. So, in the previous example, if I wanted to know the z-score, I should subtract my grade, 6.3, to the average, 8.2, and divide the resultant value by the standard deviation. What the z-score shows us is how much you differ from the average in units of the standard deviation. And this deviation can be either positive or negative. If your value is smaller than the average, then the z-score is going to be negative. If it's greater than the average, then it's going to be positive. In many situations, what you want to be is above average. In the previous class, we used the quartiles to calculate the interquartile range and the semi-interquartile range as measures of the spread or dispersion of a distribution. Here, we are going to look at the quartiles as measures for us to situate the relative position of a given value in relation to the whole distribution. As we've seen in the previous class, the first quartile divides the 25% in lowest ordered values from the remaining 75%. The second quartile, which is equivalent to the median, divides 50% of the lowest ordered values in relation to the remaining 50%. The third quartile divides the 75% lowest ordered values in relation to the remaining 25%. We can have a better idea of the meaning of the z-score and the quartiles by looking at these two graphs here and by looking at the values that I'm presenting to you in the bottom of this slide. This is the frequency distribution of the variable temp. We have already seen this distribution many times in this course, but what we want to know is we want to take some temperature values and we want to investigate what's their relative position in relation to the distribution. If we calculate the mean and the median of the variable temperature, we can find the values 18.89 for the mean and 19.30 for the median. The question is, what is the z-score for a temperature of value 5? When we look at the temperature 5 here, we can see that it's way to the left of the mean. And this means that it has a negative z-score, and after we calculate the value of the z-score for the temperature 5, we observe that it is equal to minus 2.39. And this means that the temperature 5 is minus 2.39 standard deviations from the mean. We can do the same calculus for the temperature value equals to 10. It's still on the left of the mean. Temperature value of 15 is still to the left. Temperature value 20, it's slightly to the right of the mean. And this implies that the z-score is going to be positive. For the temperature 25, it's more to the right. And for the temperature 30, it's even more to the right. Almost 2 standard deviations to the right of the mean of this distribution. More specifically, it is at 1.91 standard deviation to the right or greater than the mean value. This graph or this visual that I'm presenting you here is called the box plot, also named the box and whisker plot. What we have here, we have the minimum value of the distribution of the variable temperature. We have its maximum value, and here we have Q1, Q2, and Q3. The box plot gives us a good idea of how the temperature values are distributed from its minimum to its maximum value. The points that we have here are outliers, and they are calculated as a function of the interquartile range. They were automatically calculated by the software that plotted this figure. In our course on data visualization, I give you some explanations of how these tools calculate these outliers based on the interquartile range. For now, all you have to do is to understand what is this distribution and how it is calculated. Thank you for watching and see you in our next class.